before. And thanks for recording this, Bill.
Yeah.
Paul was leading up the ARRLEME contest event. I was down there last month participating for the last 3 days or 2 nights of that event. There was 2 nights, Friday, Saturday. I attended Saturday night, and there was only four of us down there, but we had a good time. And we also had our VK6 member from Australia joining the group, and he was there as well, making remote contacts. So, Paul, you want to go ahead and lead us off and tell you what went on and how many people showed up, and how was the food? Did Alex cook a good breakfast like he did last time?
All right, let's see if I can share my screen. Let me get to pull up a slideshow here if I can. I'm not very good with beginning. All right, well, okay. Let's see, share there. And what am I going to share? Okay. Let's see, which one is it? This one here. I'll try this one. Can everybody see what I'm looking at? I
Yes.
hope. All right. So, yeah, we had a great time for the last 2 weekends. First weekend was when Alex and I went down. Roger and Ray were down there earlier working on resolving a connectivity issue we had with our coax, our feed line going to the Diane box that's up in the feed point. And anyway, so we did have quite a few people. I'll get into that in a second. We got some feedback from some of the folks. Betsy Barnett from the Kiowa Independent wrote an article, which was actually a couple of articles that, or more than one article anyway, that she wrote. And this last one was picked up by the ARRL. I did not forward it to them, but they actually took the actual article and posted it as part of their hams in the news. And anyway, we just got this note from Scott Poynton from the Los Alamos High School, from their Science Olympiad team, and he wants to see if there's a way that his folks or his classes can come down for a field trip. And this is, totally unsolicited. He wrote to her asking for the contact information. And now that he's learned that there is some information, or there's some science going on down here, and I'm going to reach out to him, but I'd like to maybe check with Dan and some of the other folks who are going to be doing the astronomy work and find out when they're going to be doing the next pulsar and Mazar search. So that would be good for them to have, even just to go down there and see everything that we're doing and what it really does. So that's just one of our one of the things we got. Oops. Oh, heck, there we go. Here's some more. It's a little bit smaller, hard to read. I got to put my glasses on. Darn it. Yeah. So another gentleman said he attended an open house and likes the EME information, and his calls KS6T there in the Black Forest. So he's probably not too far from Rick, and he'd like to see if he could copy us during the contest. And I'm going to follow up with him and just see if he wants to get more hands-on involvement in future events. And then there's this fellow Tim WW8L, and he was at our open house, and he wants to see if he can see the dish being used in astronomy. So we're getting some astronomy, definitely astronomy interest from all of our recent activities. So we got some funny feedback from some of the folks on the New Jersey and the East Coast, and they're complaining that the DSES dish must really be owned by an institution and not owned by hams, because nobody could own a 60-foot dish. And it's not a fair advantage for a group to have a 60-foot dish in a contest. It's just too big. Yeah, tell me about it. If you look at some of those low band antennas, they're not exactly small either. However, so we figured we tried to come up with a solution, because we really don't want to have all these guys upset at us, So we have a solution to the problem with the 60-foot dish. This is our new EME array and setup that we're going to be using in the future to do moon baths, and we'll still beat the hell out of them. But we just thought, we put together a photograph so they could see it in advance, and maybe that'll get them interested. So anyway, that's our new solution at Haswell. Some of the attendees, man, we got a lot of folks. I don't think I got them all. I had them all written down in a book, but unfortunately, I left the book on the table in the down there at Haswell. So, but I was keeping a list of everybody, and all I can say is there was a lot of people there. I mean, the place was jumping.
Hey, Paul, the guy from, I think was it Doug from Chicago?
No, that's
Larry.
that's that's Larry
Larry.
N7MZW.
Oh, it's Larry. Okay, N7MZW. I'm sorry.
It's
Good.
okay. Yeah, he drove down for the first event and came in around 9 o'clock at night in the middle of that storm, and we and he helped us in terms of getting the dish working. Now, I don't know if anybody does not know what happened then because it was published in a couple of instances, and I think I put it on the DSES Group IO as well. But we had a major storm there on Friday night, which was not forecast by the Weather Bureau, and so Alex and I went back and got the make sure everything was batted down as best we could. The dish was in the right position and everything. So, and then the next morning we found out that a chain had broken when I tried to turn the dish. And I don't think it had anything to do with the weather. I think it was just the chain was just worn out and broke. And we ended up going to Eads and going to the Napa store and getting a replacement thing. And so Larry and myself and can't even talk today. Alex put together a solution, and Alex installed it. So we're
Hey,
back. Yeah,
Paul,
yeah, Mike.
correction on Larry's call sign.
Oh, okay. I screwed up.
It's
What is it?
N7 Lima Whiskey Sierra.
Boy, that's off. All right, let me see if I can fix that. No, I can't fix it. Well, all right, I'll fix it later. Yeah, I thought I got it off of thought I got it off an old email, but probably not. But thank you for catching that. Anyway, I'm sure I missed some folks here, but there was quite a lot of people there. Here's just a couple of pictures. I took a bunch of photographs and see if I can bring them up onto the screen. Now, it's easier said than done. Well, I'll show you those in a minute.
Yeah, Paul, I think I counted 8 people the first night and 9 the second night is the count I had, but people showed up after I left the second night.
Right. Yeah, more people showed up. There was a couple there um, who I didn't know, and I should have. I wrote their names and stuff down in my book, but as it turns out, I'm not very good at keeping this stuff. Let's just see if I can get close the screen. Come on, Paul. Escape. There we go. Yeah, so here's some of the photographs or the pictures we took. Let's see. Come on, Paul. Next one. This is the sleeping quarters that the folks put together. So a lot of folks slept overnight there, and they operated right into the middle of the night. So a lot of activity going on there, and we picked up a few more contacts that way as well. There's Alex. Here's LD, and I'm not sure who's behind him, but if it could be Ray, I'm not sure, but they were actually I don't think it's Ray, but they're getting pictures down from the space station. There was some SSTV work going on.
I think that was Roger.
Roger, okay, it's probably more like it, yeah. And of course, there's our. Oh, yeah, this is the article that was in the paper, and there's a picture of Alex with
Yeah,
his
and
hand up in the air.
Alex has reposted that in the chat. So the link to that article is in the chat if anybody wants to read it. It's kind of hard to read on the copy in your picture.
Really?
Yeah. Well, even when it was blown up, it was almost impossible to read, but
I know, I can't believe it. But anyway, we have the article that actually is in two columns or one column, so you can read it better. Anyway, yeah, they put LWS was N7 LWS was his call. Is that right, Mike? Did I get it right? LWS in
Yeah,
the
that's
article?
correct.
Yeah, that's correct. Okay, good. Yeah. So they're able to get our call signs at the end of the article. But it was kind of cool. And I got another note from Betsy. She wants to know how the contest went this weekend and what are scores and how many people we talked to and so on and so forth. But I'm going to let Alex talk about that a little bit more because he was keeping track of the number of people we actually worked. Anyway, with that, could I, Alex, could you talk a little bit about this? Because you're very instrumental in a lot of the activities, and you could explain some of the we had some challenges. Actually, challenges where the dish wouldn't move again, but this time it was a different problem. But I'll let Alex explain that.
Yeah, can you
And
unshare, Paul?
I'm just looking here. There, I see stop share. I got it. Okay.
Yeah,
Thank you.
well, we had a little bit chat with Bill about this, trying to find out. See, I witnessed a lot of things that concerned me, and we try to understand what the root cause is. But everything points out that it's a perfect combination of the noise generated by the elevation motor, and and happens when you just ending transmission and sending command to move the dish up. Not dish down, dish up only. So we had verified that very many times. So we need to investigate this a little bit closer, but since we're running new lines, power lines for EVE 25, as well as the grounding. So I would wait until we get the final installation, and we see if this issue still occurred
Yeah.
or not. Then we'll work on the source side, not on the load side.
Yeah, Alex, I'm sharing a window. Can you see that?
Yes.
And that number 3 there is that issue that we're talking about. And it's a little detailed, but I wrote down everything I could think of on it, and I'll share this with the group in the notes.
Yes, correct. I verified that. I witnessed that at the very beginning when between 0 and 30, we don't have this issue. And it starts around 30 degrees and runs all the way to 60, 70. But when it passes 70 degree, it never occurs again. All the way back to the 0. So it's something with the current that the motor draws when within that elevation frame. So we have to go back and perhaps what we discussed to use a probe to verify what amount of current and what kind of waveforms we observe on the power lines, and we go from there.
Yeah,
Other than that, I don't have that
well,
any we
well, the other problem we had was the elevation encoder connection was intermittent.
oh yeah,
And you and
definitely.
Ray crawled up and fixed that, and but that's the third time that's happened, and so there's some intermittent problem with that cable plug that plugs into it's an Ethernet based encoder, and it doesn't have a Cat5 or a RJ45 type jack. It has a round small pin and sleeve plug, and for some reason that thing has disconnected. This is the third time, and by just unplugging it, plugging it back in, it fixed it. So we're going to have to go after that one too.
So I have a quick
But I
question.
was there. I was the guy who was removing that cable, and from my observation, what I saw, and I gave some couple suggestions to Ray to do, because in order to just observe the lights on the sensor, is the sensor powered or not, we have to open the entire cover. So we just need to make a small window on the plastic box that's sticking out of it. And it will allow us to see inside. And also, if you make a small sort of like a cover that we can easily open it from the plastic side, we don't need to unscrew those 16 bolts on that big cover. So there is a way to fix the easy access. When it comes to the back connection, when I remove the connector, I look at the connector in internally, there's 4 pins and there's socket pins. They were big. I think they were too expanded, so they were not making good contact. I just squeezed them by my hands because they were sort of like soft plastic housing where they insert, and squeezed them and I plugged back in, and it worked fine. So I'm assuming because of the temperature variations, when it's cold, when it's hot, I think it's just metal contracting and expanding and what causing intermediate connections. You can fix this to kind of remove that connector and make something else using different type of connector. We're looking only on 4 wires, so you can use any other connector that wouldn't be subject to environmental effects.
So I had a quick question about the connectors and stuff. After you squeezed it and put it back on, did you run the rest of the night without any problems?
Correct. Yes.
Did you run again another night after that?
Well, no, we all left, so
Okay. I was just curious. So basically, when you put the connector back on, then you were able to run the rest of the evening
yes,
without issues.
yeah, it worked fine, no problem. So we were able to operate until morning, and we did some technical experiments before we
Okay.
left around 2 p.m.
And that cable is a power over Ethernet cable. The power goes across to that device via that connector and that cable.
Correct.
So, okay, I was just curious. I had seen that problem also when I was down there, and it cleared itself out when I changed the connector, or excuse me, the cable at the switch. We'd never touched the connector in the back of the encoder itself in the past. So that's good information to know. So thank you.
Yeah, it was very helpful, Glenn. Thank you very much when we call you, because we couldn't figure out what's going on. Until you told us that particular IP address for the elevation sensor, and we never saw that IP address. So give us an idea right away. So the sensor is not even connected to the network.
Right.
It was clear when we get to the pedestal and open the white cabinet, we saw there's no blinking LED on the router for it. So it means there's no power, but we didn't know on which end the problem is.
Yeah.
So we
I always assumed it was on the switch end, but it sounds like it must have been up in the
Yeah, because Ray told us last time when you had the problem, you had to unplug the RJ45.
Right.
The problem, which wasn't the case. So we had to go up and open up to verify that there is no power coming there. And that's why we had to investigate. But it was quick solution. So at least we know what's going on now, and we know what area we need to attack if it happens again.
Great. That's good to know. Thank you.
Alex, the only other issue I saw with the actual mount on the dish was the large noise that the elevation drive makes. And you had mentioned that. And there seems to be much more stress on it in that 30 to 70 degree zone. And it makes a lot of noise. Ray and Paul removed one of the jack screw gear covers, and they inspected the lubrication. This is about 6 weeks ago. And so I got different stories from Ray and Paul on how good the lubrication was in that box. And so we need to come to some conclusion on that, and whether we need to re-grease those jack screw gears.
Yeah, because the noise is not really, I mean, I was surprised when I heard it. I've never paid attention, But since we were running under back and forth to switch the Diane's power, we observed that noise. And the first time when I heard, I got scared. I thought something is falling on my head. It was very strong signal. I mean, very, I don't know how to describe it, like a metal in a grinding sound. So it's kind of was unpleasant to hear, but definitely we need to revisit and see what possibly can be. Is there any possibilities that we don't have proper balancing between the weight of the hub and the
Well,
content on the
yeah,
back?
the only thing I thought of about this was when they built it, they added those big concrete counterweights. And then it sat there for a long time, and we don't know if there were additional weights or not. There might have been additional lead weights at some time on top of the counterweights, but that's just conjecture. I don't know that for certain.
Oh,
Don't know, have any clue. But
Bill, how long had it been sitting there? Was it always bathtub set
yeah,
between?
it sat in the bathtub position as far as we know for 50 years,
Oh, I was just wondering
or bird
had
bath position.
if it had been sitting somewhere where it was always working on a little piece of the screw, or if they used it at one particular elevation for back and forth, back and forth, back and forth. In other words, if there's some point in the screw itself
Hmm.
that's had more wear
Well,
than some other place.
that's a good point. Most of the for tropospheric scatter, they would have used it in a horizon pointing position most of the
Yeah,
time.
near horizon. Yeah.
Mhm.
Okay. I just wondered if that was possible.
Yep. Anyway, so something to look at. Figure out what we need to do with that, and it could also be that the motor inverter controller is not putting a good signal on the motor, and that would make a lot of noise as well. So we need to investigate that. Ray has I think Ray said he had a large clamp-on scope probe, and we can
Hmm.
look at the motor drive currents and stuff with that.
Is it a three-phase variable frequency drive?
Yes, three-phase quasi-square wave variable frequency, variable pulse width.
Ah, boy. Wow. Could be anything.
No, but I
Oh
mean,
dear.
it should have a specific signature in the waveform.
Yeah.
And if
Yeah,
we
it
see
should.
that that's
Right.
wrong, that would tell us something. That would also, give us some clue as to number three. If we were to measure the currents of the motors and look at currents on the shields of the coaxial cables, that might also give us a clue as to what's going on with Diane and the susceptibility that's hanging it up.
Right.
So I was trying to understand this from the electrical engineering perspective.
Mhm.
I'm pretty confident on my end that issue number two, number three are part of the same. We just need to find exactly what the root cause is.
Possibly.
But what's happening? We don't have a proper grounding because we need to understand that the noise source is located underneath of Diane, closer to the ground, and then Diane is grounded further up. So there is not good grounding. So even noise exists, there is no proper filtering going on. So
Right.
and that happens when you are start transmitting, but sequence are still engaging your transverter, and the motor start running, and that's what allow the ground shift occur and is keeping the transverter in a transmit mode.
Yep.
But the amplifier switch is off. So, and this is why we lose the receive, because internal relay in the transverter stays engaged. And that's because the difference between the actual ground reference and potential, that causing this voltage to fake the ground signal. So that's what from my side is what's going on. And I saw a few times it's been released by itself, but another spike. So it was subsequent spike when the motor ran and it was releasing that resetting sort of transformer.
That's that's right, isn't it? Those most of those TR circuits are pull down to ground, right?
Correct. Yes.
So if the ground gets a little faulty, it can pop up again and disengage or whatever. Yeah, I think I agree with you.
Yeah, that's
Sounds like a grounding problem.
it's only one thing I have in my head because there's nothing else. There's no explanation behind why it's happening. It will
Yeah.
never occur if you're gonna. I ran this Diane on the bench for hours and days and weeks. I've never ever was able to replicate a problem. It only
Hmm.
occurs between 30 to 70 degrees elevation.
Yeah. The only thing that helped this situation, now this is a grounding issue. We had it so bad that we could hardly operate on the first try about what it was, 9 months ago. And what we did was Ray added a wire from the hub where Diane is located to the waveguide, and then I added a wire from the waveguide through the azimuth collar or its axle to the dish pedestal chassis, and that improved it. It got, was about half as bad as it had been.
Huh.
And that's the only clue that we have. Everything we did to the power, we put filters on the power line going up there. We ran them off of a UPS. We ran them off of a different AC source entirely. None of those things made any difference at all.
No, it wouldn't.
But the
If
thing that made a difference was grounding. However, there's other things that can happen in the grounding and the connection. Like if say we lost a wire on the three-phase motor, that current may try to return through the coax, through the coax shield, and that would really screw
can
things up.
it
So,
can be, but don't forget every time you change metals on one of those ground lash ups, it's a diode.
well,
And
eventually it's a diode,
yeah,
right?
so it's
So
like,
that's a problem too. We have to have a good solid bonding of any of these connections to the chassis, or we're
yeah,
wasting the whole.
I bet you when the ground gets settled down, it'll be better.
Yeah,
But I almost would think,
but I still think it's the
I would
injection kind
almost
of
think a
problem.
separate. So if you're going to have a a a push to talk signal of some kind that's that sensitive, that's over that long a path or something, that
Well, that's something else we could do is put a secondary relay on the key line and
you'll
reduce
lose about 50 milliseconds. So
well,
um,
we would reduce the length of the line. The line right now is 200 feet.
oh dear me. Yeah. Almost seems like a separate twisted pair would
And
be in
let
order.
me say one other thing, Don, before we get too far into that. The other thing is that the motor drive signals, the motor power signals, there's three-phase motor power. So
Yep.
it's three
Yeah, sure.
wires, and those go through the collar in the azimuth axis. And those go through that collar with our control signals and with our coax signals. And so,
Oh dear.
these are high currents in those motors, and the
Yep.
higher the
Yep.
current, the more induction you get.
Yep.
So there's that possibility too. So we've got to get in there and get in with a scope and actually measure it and see where it's coming from.
Yeah, and
Yeah.
we also can put the probe on the Diane side and see do we see those spikes in there because it's a pure EMI problem there. We just need to find a source. And then we can easily identify the rest. We know the path of the ground line, because by shifting the ground reference, the whole box is floating now. So it's not right. And then you have another ground reference at the shack. So the difference between the ground from one end
Yep.
to another end causing all these issues. It's not normal way. So we know what's going on. We just need to get fixed.
Yeah. If it fluctuates by 1 VBE, the way those things are made, Usually that's all it would take would be one couple of volts of spike could lock it out or lock it in. I think I agree. It'll be better once the grounding is settled. And
And the
and
new
you're right,
proposal,
looking at those, I mean, the variable frequency, variable width drive is just inherently a noisy mess.
Yep.
And there, like you say, it's going through that collar right next to everything else. I'm not surprised. I guess that it's probably. I mean, it could even be just as you say, coupling to the line itself, to the PTT line itself.
That's possible, and that could float it, and make
there is
it.
a different threshold because it occurs only in specific angle. So we assume that between 30 and 70 degrees of elevation, it's enormous current to the motor's draw, and that's what causing. So that is the threshold for the Diane to be susceptible. But everything other positions, the noise is not enough amplitude wise to upset Diane. So when we measure it and we try to fight and reduce that noise, we can still operate as is configuration until we get infrastructure for EVE 25, which going to be a fiber optic controlled system, no wires, because it's not, it won't be susceptible to any noise whatsoever. And I also
Good
have
idea.
a file to share to conclude the IRL EME contest. I think it beneficial everyone know how many queues we made and what countries we worked. I put all in one small file. I'll take a minute so I can share that and show how many points we've got.
Okay. While you're doing that, let me say one more thing about the drive chain. Alex took dimensions off the pulley. One of the pulleys, or I should say a sprocket, a chain sprocket on the azimuth drive on the dish. The one on the dish side of the chain, not the motor side, but the dish side of the chain, is badly worn, and we need to replace it. It looks like little sharp teeth, and it should have pretty solid gears on it. And so that's a vulnerability that we should fix as soon as we can. And it has 25 teeth, and Alex took the dimensions, but we don't have the dimension of the center axle. So we need that dimension off that pulley, and we need to find a purveyor that can provide this gear and put a new one on there. So that's all I got. I'll unshare if you want to share your data, Alex.
Sure.
Also, one last thing. We've cleaned out for various reasons. We cleaned out the trailer, I think, for open house, and a lot of stuff got pushed into the pedestal. And the bottom of the pedestal of the dish is full of junk, and we need to clear that out. I moved a few boxes back to the building, but we just need to go through there and clean out the bottom of the pedestal because there's so much stuff in it you can hardly move around in there. And we just need to do some housekeeping. That's all I've got. I'm going to unshare this and give it to you, Alex.
Alex, did you say you had the information on the number of contacts you made?
There you
Alex?
go. Yeah, I'm going to give him the share here, and he's going to.
Okay. While he's doing that, I want to thank Paul and Alex for leading up this event and all the folks you hosted down there this weekend. It was really nice to have the attendance we did down there, and the interest from the other local folks in the school area, local school system, interested in coming to our site to do some radio astronomy work, and hopefully we can coordinate that and get that set up and have a good presentation to give them. It may not happen anytime soon, but hopefully we can get that on the schedule for later in the coming early year. One quick note, Mike Parson, did you make another YouTube video for this event?
I did. I got quite a bit of video this time, so it's probably going to be a little bit longer.
Okay,
But I gotta, edit all of it, so it's not just a lot of empty space.
sure. Well, thanks a lot for coming down and doing that. Mike produced a really good video for the open house, and I sent that out to everybody, and it showed up on the ARDC website as well a couple months ago. Okay, Alex.
Hey,
What do
one
you got?
last thing,
Yeah,
Myron.
go ahead.
I'd like to call out Larry from Chicago, N7LWS. He apparently stayed around on Sunday and cleaned the kitchen and the bathroom. And so his mother taught him well. So yeah, we really want to thank him for that. I don't know if he's online or not, but everybody should thank Larry for keeping the site nice and neat and tidy.
Yeah, that's great. That's what we got to do to keep that site in A1 shape. Is everybody pitch in and help clean up
Yeah,
after
there were
a large
several
event.
there were several
Cool.
other guys who did the same thing. So it was a continuous operation. It was great.
Yeah, everybody did a great job of keeping the floors clean. Everybody took their shoes off, put on different shoes, or just walked around their socks in the building, and we got very little mud into the building. So that was great. I really appreciate that, guys. Thank
Yeah.
you.
Okay, Alex, tell us what you done. Looks like a lot of good contacts.
All right, so you see this screen, right?
Yeah.
Okay, so just want to mention the contest was 2 weeks. So we had first week in October 20th, and the second week was in November 17th, the 16th, 17th. So combined number of contacts is 163. This is what we have in the log. Appears to be we have worked 27 dupes, mainly this week, last week. We worked total grids 113, and that's an important factor because that's our multipliers. As many grids we work, as more points we'll get. So after all this cleanup, we have total verified contacts 136, which would be counted for the points. And do the simple math because every single contact is 100 points per IRL EME rules, and multiply by the 113 grids that are multipliers, we end up around 1.5 million points. I think that's the highest score ever a DSES, a K0 PRT had in EME contest, and I think this is the way to go for us. I'm not sure if we first place or not, but I can definitely say we're in top 5 in the world. That's what we should be. So I now broke down by bands and everything else. So we work 9 CW contacts. Thanks, guys. I think 3 guys who were working CW, including myself. I'll thank everyone who contributed to that. We did not work anyone on the phone because majority people were operating CW and digital mode. We managed to work 154 digital contacts. If you look at the country list, it gets pretty interesting because it breaks down how many queues we make for each country. The most QSOs, obviously, United States. Second is Germany. Third is surprisingly Russia. I did not believe when I saw, but it appears that we work 12 Russian stations. And then Italy and a lot of European countries. Worth to mention, we work 4 stations in China. We work 2 stations in Hawaii, 2 stations in Indonesia. This Bonaire I want to highlight because this is unique QSO. It's one of a person that some of us know, Martin Papa Juliet for Mike. He was making his first QSOs in an EME contest. He was operating straight from ICOM 9005, which is 10 watts, over about 30 foot of cable and 6 to 7 element Yagi. We're able to work him. Only 4 people in the world were able to work him. We were 5th station he worked. He'll be in my house on Thursday. He'll bring and handle a QSL card, and I'll bring that QSL card next time to K0 PRT. I think this is that we need to recognize this QSO unique to us because it's it's a hard to work such station. We were able to do that. We work Malta. That's also considered EX. This is also unique here. So we work Saint Bart station. It's Alex from Echo Alpha 8. He is on his journey in Caribbean EME expedition. At the time of a contest, he was on a Saint Bart, and we were first station who he worked because we were the strongest station on his display. So he sent a text message to me saying that you guys were the strongest so far I've heard. And he had a portable umbrella dish and just 200 watts on it. So total countries we work, it's 31 DXCC. I think this is the highest number we ever worked. This is also interesting fact. The total DX miles, take all the SKUs we made and the grid squares, we cover 650,800 miles. That's more than round trip to the moon. This is how many stations and the distances we covered. Average miles per Q or so is 5,700 miles. It's interesting when you look at this data after contest and you see where you've done it. It's fascinating. This is the average bearing. So basically, it's not important data, but also cool to see what bearing mainly we use to operate and work many stations. So North American 66, which looks like it's a moonrise for us. Moonset Asia, and mainly done by VK6 Papa Yankee. So he worked most of Asian stations for us overnight, as well as Oceania and South American and Europe. Total contacts per continent. So we work 5 continents. I was sad to hear today one of South African stations, Zulu Sierra 6 Yankee, contacted me and apologized he could not work us. He only operated in first week at the same day where we had storm. So we missed Africa. There's only one continent out of 6 where we couldn't work, and only one station operated from there. As you can see, other continents been covered. We worked 18 CQ zones. We know that the work at all zones is 40 total count. We work 18, and we're slowly getting to number of 25. If we hit 25, we can apply for award. On these frequencies, you don't need to work 40. 25 is a bare minimum to recognize by the committee. We're close. All right, so that's just statistics of the 2 weeks of the contest. And compared to previous contests, this is the best so far. And thank you very much for everyone who contributed, who operated, and made this happen for us. That's all I have.
Okay, thanks, Alex. Alex lives in Chandler, Arizona, and he flies up for this event. He's done it 2 months in a row, and when he's not flying to Colorado, he's down in Honduras somewhere in Rotan doing DX down there. So he's a busy guy, and as well as he'll be our EVE chief engineer as well. So thanks again, Alex. Anybody have any questions concerning what Alex presented and his statistics?
I do. Who's going to submit this to the ARRL?
Alex.
We'll submit I need to verify a couple things, make sure that we don't missing any information. And after that, I will submit to we have a 30 days from the last day of, so we have a plenty time to submit.
Very good.
Okay. All right, we've covered that extensively. Now let's keep the thing moving here. And the agenda is building update, Bill. I know still a lot to be done down there, but overall it was a good facility for what we did the last 2 events down there for Moon Bounce. So what do you got for us, Bill?
Yeah, let me see if I can get under my taskbar here. Hang on just a second. Things never work the way I want them to.
I want to thank everybody else that joined. We're up to, I think, about 27, 28, if not more, folks joining tonight for having a last minute change of a Zoom information. It was, thanks everybody for joining us tonight.
Let me jump into the building. So before the contest, we got a few things fixed. We got the water heater working. Turned out there wasn't really anything wrong with the water heater. We just had the faucets hooked up backwards. So once we got the faucet squared away, we realized that the water heater was actually working. Also, have a timer and contactor on the water heater and on the cistern pump, and that was giving us a little bit of problem. I put an extra relay buffer in that, and tightened all the contacts on the contactor, and that seemed to solve the problem of the buzzing contactor. So we got the full water system working. Everything works. You push the doorbell button above the sinks, and it turns on the water heater and the cistern pump, and you got hot water and cold water, and it runs just like a normal sink. Let's see. The other thing was we had the contractor come out with his helper, and they installed the last heat register, cooling register on the Mr. Cool heat pump system. And so that all worked, and we had good temperature control and heating of the building. And so with the heat pumps, we have both heating, cooling, and dehumidification of the building. We did have quite a bit of humidity in the building. The building is sealed tight with the polyurethane foam, and Roger noticed that the windows were running streaks of condensation off the windows, and is concerned that we might get a mildew problem if we don't dehumidify the building. So we have to look into that with some gable fans to exhaust the building, and possibly dehumidifiers. But the heat pumps actually do have a dehumidification process, but I think it only works in the summer months when you have the air conditioning running. So we'll have to figure that out. These are some of the things that we still have left to do. I talked to Corey Miller, the electrician, and asked him while he was there estimating the new power system for the pedestal and the dish for EVE. I have been after him to finish all of the outlets in the building and all the light fixtures above the doors and all the external outlets. We've got about 7 outside power outlets, which is far too many for power. You plug something in outside the building, like a leaf blower to blow the dirt away, or a pump, or a tire pump, or whatever we want to do. But anyway, so he's gonna work on that, and promise me that they'll get the building finished, the electrical part of the building finished. We need to seal the building plate, the bottom plate to the slab interface, with some caulk, and along the whole northern side of the building to prevent it from leaking. We had water come up against the north side of the building from the north pasture back there, and it leaked into the building in several places and ran under the cabinets. And so we got to seal that up so that can happen. Also, one of the things I need to add to this is I've got to get Kyle Barnett back with his excavator or his Bobcat, and have him redo the grade of the land away from the building, so that we have some sloping down into the road and away from the building on the north side, because that water comes down and backs up against the building. So when we have these big storms, we have some leakage that we have to fix. I got some Mr. Cool outdoor line covers on that last register I need to order, and we need to get some gable fans in there to get the heat out of the top of the roof and the moisture out of the top of the roof. That's just one of those things that was the last thing on the list. And then add a vent between the control room and the main presentation room. Need to terminate all those Cat 6 cables in the home run either in a box or in the rack, and terminate those and attach them to a 100 gig switch, and get that all hooked up so we have Ethernet, and also terminate all the opposite ends of those cables with RJ45 wall plates. And then we need a bench and shelving for the bathroom. Like this would be like a 42 by 18-inch padded bench that you could sit on to change clothes, whatever, in the bathroom, and probably some shelving to put towels and that sort of thing on, or a locker system. We come across lockers every so often at the Restore store here in Springs, but if we could find a small locker set, we might do that. Need some more grab bars and a towel rack in the bathroom. Grab bars for the American Disabilities Act compliance. Purchase and install a bench and toolbox, like a workbench and toolbox for the building and the main control room. Purchase and install 2 additional shelf units in the garage. And then window shades and window security bars. And we're looking into that. And then rekey all the door locks, since we've had all the contractors down through there, and repin all, or not repin, but reset the combination locks on all of the access points in the pedestal, the dish, the bunker, and all of that. And then we need to devise a cistern pipe lock device over the 4-inch fitting on the cistern pipe, the fill pipe, so we can lock that and make it tamper proof. So those are just some of the things that are left to do on the building. One thing I didn't mention here, we talked about it for the EVE project, and that is Paul had the electrician estimate what it would take to do the grounding system around the building and do the bonding to the building for a lightning strike and bonding of the building. So we do that both for the building and for the pedestal of the dish, and then tie those 2 systems together so that we have as good of a bonded system as we can for lightning strike and preventing static electricity and all that sort of thing from messing up our equipment. So that's about it. Any questions on all that? And I could use some help with any one of these things.
One thing I want to emphasize is, and Bill will say the same thing, if you have any items that you think DSES might need in that new building, don't bring them down until you talk to Bill. The last thing we need is a whole bunch of excess furniture, equipment, and stuff for, pots and pans, extra this, extra that you think you don't want to throw in the trash at your house, and you bring down there and give it to us at DSES. We've been through this iteration in years past in the bunker, and we've gotten a lot of donated stuff, and we've donated most of it to the dump. So
That's right. Yeah,
so instead of us being the dumpster, you guys can donate it to the dump. But please ask Bill before you bring anything down. We may need it. We may actually use some of the stuff you have, but please don't bring it until you talk to Bill.
Well, as an example, Paul found a really nice conference table for our control room, but the guy had to get rid of it right away, but we had no way to really move it. We were all busy and couldn't make the trip to Denver to pick it up, but it was for free. It was really nice. That would have been nice. But then other things like Paul wanted to bring a couch. Well, I don't think we don't need a couch. But we are looking into chairs for the presentation room. That's one thing I forgot to add here, Myron, the chairs.
Yeah.
We do have most of these things plugged into the budget. So we have the money to buy them. I've been trying to buy most stuff that I can at a discount from Goodwill, the Restore store, the appliance providers that have scratch and dent, that sort of thing. We've gotten really great deals on everything I've bought so far. But like Myron says, if we just bring stuff that we think we may need, it just ends up getting in our way mostly, and we have to haul it off. We've taken trailer loads of stuff out of the site that was brought down there by all the previous members. So be careful with that. I appreciate it.
Any questions for Bill? Yeah, the building that those people attended the both open house and the EME events have seen a lot of progress, and it's continually gets to be a first class organization when it comes to operation down there, and hopefully we can continue to keep it that way. Next on the list, we have the EVE, Earth Venus Earth Progress Update. We have Paul Sabone, our chief project manager, and Alex, our chief engineer, and we have about 8 or 10 people associated with this group who provide input as well, how things should be done or not to be done, and so that's how that is working. I'm doing the buying of the equipment that Alex tells me to buy so far. We've got about close to $12,000 spent on the equipment out of the grant money that we got. So Alex, or Paul, you want to continue on?
Myron, I've got a note here from Paul that he wasn't feeling well and dropped off.
Okay, understand.
Yeah, I can fill some information. I'd like to share the screen again. I did some timeline, so everyone can
okay.
see what we had.
Let me give it back to you, Alex. I'm sorry.
Sure.
Go ahead.
Okay. Everyone sees?
Yep.
Oh, there we go. Yeah.
All right. First of all, thank you, Myron, for help with the purchases, because as we can see, we're in that stage right now. So let me walk through. I didn't want to overcomplicate, but it looks like it's a lot of color. So let me explain what we have. So on top, we have months: November, December, January, February, and March. So basically, that's what we have. Because March itself going to be an execution, mainly third and fourth week, but we should be ready by beginning of the March to have fully functional system. So I broke the tasks we have, as well as the milestones, important milestones, and some delivery dates, what we need to deliver. So right now, as we can see, we're in the second week in November, actually in the beginning of the third week of November, which we need to start assembly of our subsystems. And I sent about a week ago an email when I described what subsystems are, of people and roles, responsibilities, to have a generic idea where we at. So I will start assembly based on the parts I already received. I started receiving parts. I think 3 orders arrived to my house so far, Myron, and 1 arrived to DSES that needs to be shipped to me. It's the power supplies. Those are essential parts, and I would need them as soon as possible. But I can't start assembly until I get the German package from Cooney. Those parts need to be arrived as soon as possible. So meanwhile, I'll start assembling a transmit sub module, which gonna be shipped to Colorado to Dave, Alpha Alpha Zero Radio Sierra, who is our test and evaluation engineer, and will be testing in his lab while I'm gonna be continuing assembly. So the next, as you can see, the next milestone is a system start test day. So basically in 2 weeks. In 2 weeks, we should have something already built, one of the subsystems based on the components we have, so we can start testing it. And also we know that we have a holidays now going on, the Thanksgiving and Christmas and New Year. So I don't expect 100% efficiency, but we'll try our best. Assembly is not complicated as long as we have all parts. I have all machines we need, so I don't need outsource anything. I can cut, I can drill, I can laser cut, I can CNC, I can 3D print, whatever. I have everything in my lab to support that. So here on the bottom, I indicated the milestone. Let's count this week as the first week, because we're starting assembly with the parts we have already received. And as you can see, until the EVE, we have only 14 weeks left. So we're going to be slowly moving. The red vertical line represents where we at as today. We're going to have engineering meetings. We're going to update and see where we at and what the percentage of the completion is. So assembly progress and a test progress. Ultimately, we should have both 100% on the week 13. So, but it's not just a testing, it's also evaluation, possible improvement. So we need to make sure that we have subsystem fully operational in the way they initially designed. I dropped a few more things because I talked to Paul and kind of realized Dish is not in amateur radio position full time. I marked some time frame where we need to have a dish available for us to do testing. We want to do receive test systems separately using the cosmic objects, constellations or moon or anything other than sun to verify performance of the ARC system. And we'll also want to do transmit verification using moon reflection and so-called echo mode. So it looks like from second week of January until the fourth week of February, we would like to reserve the usage of a dish. But if it's not possible, we have a critical weeks where we need to have that, which is the yellow blocks there, at least 2 weeks in January and 2 weeks in February. We need to have those weeks allocated for us to complete. It's the critical milestone. If you're not going to complete that, we can't go on Eve 25. So I think everyone should understand if we determine to execute Eve 25, we need to focus on that. And if there are any science projects going on in parallel, we need to make sure we're not overlap or we're not interfering with each other. I would outsource this to you guys to board to decide, but this is the weeks that I need to have available for us to do our work. Everything ideally should be done before third week of February, and we're gonna reserve 2 weeks of end of February for training, for dry runs and final, because hardware by that time would be fully functional. That's the goal. But we're gonna have a lot of software concerns. We're gonna have SDR connections and everything else. The monitoring system's gonna be separate. So make sure all the subsystem and the computer they're running. And everyone that's gonna join us. I've heard that Skip gonna fly. Skip, I would love to have you there. Everyone should be trained at least to understand what the portion of software are for. So everyone would be, because I don't know if whatever happens with me, I'll be sick or hit by the car. I want to make sure that there are people that understand what we do, how we do, and can execute all of that. So don't forget, training, dry runs, and final tests would be critical. Not necessarily 2 weeks. It could be done within a week, and I can reserve my time to come to Haswell to do that. But at least 2 weeks in February, whoever want to participate, please be ready. Come to Haswell for that effort. So I think this is kind of like a high level of all activities associated with the Eve 25 and some important milestones and the time frame is the due dates. Things could be shuffled and moved a little bit, but we know that by March, everything should be ready. So any question about the timeline and everything you see on the screen? Looks like no questions. So
we're looking at the execution time frame to be the entire month of March.
Yeah, because the Vina is going to be approaching close within a short time frame, but German guys tried in 2009 multiple efforts when the Venus was moving towards Earth at the maximum point and then moving out. So that across about 30 days. So I put their execution, not necessarily entire marathon execution, but we will try in convenient days to attempt to do these experiments prior a closest point, Venus to Earth, where we're gonna have only one shot basically to try to get the data. Paul is not here, but we're trying to get other stations around the world involved to this effort. We did not advertise anything yet. It's been kept out of public, and we need to talk to people that capable with the big dish and antenna gain and at least capabilities of copying us. If for whatever reason we won't be able to decode our signal, but will be capable to create reflection of the Venus. So we're going to have additional stations around the world parallel copying the same signal. So will give us a backup in case if we won't be able to copy in our side. I think this week we will start contacting and reaching out those people from continent. I know some folks in Australia and Europe, and then we need to someone in Asia and North America, at least with 60-foot or bigger dish that they can want to volunteer and participate in this experiment. And that's what Paul wanna add in parallel to other activities associated with the Eve 25.
Hey, Alex, yeah, your plan looks great. I don't, for my part, I don't have any problem with the dates you have for using the dish in January and February and March. That's great because that's what we need to do. And we have detected quite a few pulsars at 1296. So during February, if we want to do pulsars, we can just do receive only mode and detect pulsars at 1296. So that's not a problem. Go ahead and plan on using the dish those dates. Also, we have a rough draft operations plan circulating to get some comments and inputs. But we've developed for all the dates in March and even into early April. Really, it's March 1st through April 12th. We've calculated the Q65 receive delay times and the Doppler shifts and all that. So we're working on that and getting an ops plan going.
Perfect. That was my next question. Thank you. Appreciate it, Dan. Because someone also needs to start working on the software side. Because as is tracking system, it won't work because we need to transmit signal ahead of Venus, and correlate the shift, how many degrees the moon gonna shift from the moment we transmit, because the difference 2 minutes. In 2 minutes and some seconds, I think it's a 4.6 minutes round trip. The signal will land theoretically on the surface of Venus, and beam width is 0.89 degrees. So we're make sure from software perspective, we have that ability to offset the tracking of the Venus. I did a few experiments on Sunday, since we couldn't use the sun noise, and it's a very reliable source, but due to known issues, we can't use it for the measurements. I'll try to use the Cygnus A star, and I was successful to measure the noise. I predicted and calculated what the noise is supposed to be based on our receive system. It turns out 4.4 dB. But I only was able to measure 2.2 dB. I was off by 2 dB. But one important thing I found when I used the celestial data from the software to get my positioning, I noticed that the peak was the antenna was moving, and then it peaked, and then it stopped. So we're not accurately pointed to the Cygnus A. That's what I'm gonna say, because it's easy for me to look on a plot with the peak. We're past the peak about a 0.2 degree or something. So there could be two issues here. The first issue, the beam width of our feed is not correct. So it's sort of offsetted. And the second, we're not pointing accurately. We're still capturing. We're not in maximum amplitude. I didn't have the time to do more subsequent experiments using other cosmic objects we are capable to measure. We can measure no problem Sagittarius. It's a big signal as well, and even moon noise. But because the contest and the time to leave, we couldn't do this. So next time I'll try to do this. But the final testing would be with the actual 1296 RX system. And I've heard about the concerns about the Doppler shift. The Doppler shift is not big. It's about 3 kilohertz maximum. So I wouldn't worry about having Doppler shifting because we can look at the spectrum and a wide spectrum. We can decode our signal regardless, even if it's going to land plus or minus 5 kilohertz. So that's where we're going to use a different software, QMAP, and other SDR-based receivers. Actually, I already received one of the SDR receivers, and I will experiment with it. So we should be able to look up an entire spectrum in parallel mode. So we're going to have a multiple receivers simultaneously receiving in and processing the data in real time.
Okay. You're right. The Doppler shift is low near conjunction, but as we get further away from conjunction, Venus speeds up going around, and the Doppler shift, like in early March, the Doppler shift was around, I think, 30 kilohertz. So it gets bigger as it gets further away.
Yeah, that is correct. So we need to make sure we understand what if we're gonna test with the first, second week versus fourth and third week, so we know what the Doppler shift will be. But once again, the SDR receiver will allow you to go further beyond 30 kilohertz. So we shouldn't be worried about that. We need to understand what area of the spectrum we should expect to get the signal.
Yep, I'm doing a spreadsheet that'll have that.
All right. That's pretty much what I have from my side. As I mentioned, I will start assembly this week, and I will update this chart for the next meeting, as well as gonna continue sending updates over email to team members that are involved on this project.
Say, Alex, on pointing error, Glenn Davis and Louis Putman had done quite a bit of work. I believe they were using the 1420 feed, but had Glenn may want to say something about this. They had quite a bit of data where they did use various celestial objects to calibrate. Glenn, you want to say something about that?
Well, I guess the first question I have is, what do you mean by pointing accuracy? Are we talking a tenth of a degree? Are we talking arc minutes? Are we talking arc seconds? I mean, what do you mean by pointing accuracy? That's the first question I have. And then after the other question I have after that is, are you expecting software changes to the tracking software to support this effort? And I don't think I've heard anything about that. So those are the first things that come to mind. But we have been working on calibrations, and we believe our pointing accuracy is getting better, but I guess I need to understand better what is required.
So I can describe in my words, I mean, what I observed, because I use the 1296 existed feed. And I can tell that I'm not satisfied with the performance, but I should be worried about because we're building another feed for EVE 25. So what I observed so far with the existed feed and measuring cosmic objects, the noise from them, that we're not reading what we're supposed to read. And the first question is why I'm low, why I'm reading low. We had this conversation with the sun noise, but sun noise we were doing pass-bys. We're just moving across in a short period of time. There are some factors affecting why we're not reading properly. Not enough dwell time or oversaturating, whatever. We were 7 dB off. And I've probably done 12 times at least, and every time is the same data. So since it was too far off from what we need to do, we needed to have an additional source to measure. and that's where we pay attention on Cygnus A. First of all, we didn't know how to operate in the software until Ray explained how we can use this declination and all this ascension to enter and paste it in the software and track it. When we did this, I was able to see the noise, but it wasn't it was 2 dB below what I expect to see based on the numbers. So it showed me that we're still reading under. But if I look at the graph, I clearly see that when antenna was pointing and tracking, the peak was behind it. So I don't know, it was in 0.1 degree or seconds difference. I didn't capture that data, unfortunately, Glenn. So I know it would be valuable for you now to understand. But
Yeah.
because I just first time noticed that, and I kind of move antenna again and let the software track it, and I saw that peak again and then drop it and I started tracking the noise. So my concern was that. But since I use the amateur radio feed that I already knew from the sun noise measurements, that we kind of have a side lobe there. And I showed that to Bill Miller. And I think Myron, I also showed Myron when he was first week there when we were doing the sun noise. We have some uncertain beam width of our feed. So that could be a problem with the feed and not the pointing issue. So to prove that, I want to take multiple sources, right? Multiple cosmic objects that are capable to receive and see if I have a tendency or, it's repeating the self in the same way. That's why if you guys saw this picture Paul posted with the generator attached to the pole, he didn't say, what is this for? So we use this as a source. We drove away in the north and the south, and he set the source. And then I was moving antenna, trying to draw basically the beam width of the antenna.
Yeah.
To understand, are we overexposing? Do we have any spillovers? Do we capturing the ground noise? Or we underexposing dish? To see what the actual beam width, because those data is available for EVE 25. I don't want to waste the time at the EVE 25 to trying to find out something. I'm trying to find out now so we can fix this for EVE 25. And one of those experiments were to verify our beam width, and I was not satisfied with what I saw. Again, I'd say it's not accurate data using the source 4 miles away.
Yeah.
I rather use a cosmic object than millions miles away, light miles away, years away, than just something is nearby that affects terrestrially. So,
Okay.
but anyway, this is my observation. No panic yet. I'll come and I'll try to do as much as possible, but I also want to make sure I have the new feed build so we can use the new feed and do the same measurements, and then to see if the software can be improved to accommodate EVE 25.
Okay, well, just a quick couple of comments. When what we've developed a process called mount calibration, and basically what we're using is celestial objects, bright celestial objects, to determine the error in both the elevation and azimuth axes. And then based on those elevation and azimuth errors, then we change the reporting of the position of the dome, or of the telescope. So that exists today, and we use CAS-A typically to do that calibration. And we feel like that we're pointing relatively good. I'm sure we can get you some information as far as what we think our pointing accuracy is using CAS-A. We've used other objects that are dimmer also. The other thing is the way that we track isn't a sidereal track. So in other words, we're not really compensating for the rotation of the Earth. We're using more of a kind of a bang bang thing where we point to where we need to point, and then we essentially turn the mount off. The object drifts a certain number of tenths of a degree, and when it drifts to a certain point, then we bring it back to the center of the antenna. So we're not doing sidereal track on an object. We're just kind of doing almost like a manual track on the object. When it gets too far off of where it needs to be, it sucks it back in. So that's something you need to consider when you're looking at the data over time, because we don't point at an object consistently based on the way that our software is developed today. So that's
Yeah,
something
and
to be
and, that,
aware of.
and that's a perfect to know, Glenn, because it's 100% relevant when you receive from sources. What comes to transmit, you have to go other way around, right? So you have to transmit earlier than the
Right.
object approaches there. What comes to receive, you're right, you can let it pass and you will receive the signal with certain peak, because what comes to science, it's different what we're trying to achieve, because you're just looking at the peak, whatever occurs after post-processing the data. So in our case, we want to make sure that the maximum peak we're looking for, it would be in a specific time, which is calculated. We know precisely, we can calculate what the Venus is going to be, reference to Earth,
Right.
right? And the distances and all of that. I think what I'm asking is just you guys look into this and see if something makes sense, something needs to be done, or we already have everything. We don't need to implement anything. So
Okay.
I just don't want find out like in the last minute if we already have all hardware done, if something is off and we didn't look or overlook and we missed it. So I'm not expert there.
Yeah.
So I want to make sure you guys look at that to make sure that on the software tracking side, we're solid. And right now, as I said, I'm not confident that is tracking accuracy problem. No, I don't think, because
No, no,
when
I'm
you
not.
use science, you're good. But what comes here, we don't use science feed. We use EME amateur radio feed that might necessarily perfect and has all these side lobes that causing this offset of a peak. So that's why I want to conduct more experiments to
Right.
understand the root cause and nature of the issue before you guys changing anything.
Well, it sounds like, that it would be great if you and myself and Lewis Putnam could get together at the site sometime between now and then to discuss at least how our calibration works and the data that we're getting. But the other thing that you're bringing up that I'm slightly concerned about is that you're saying that it sounds like you need software changes to the tracking system to be able to point ahead based on time
Yep.
and the position of Venus. Is that
You may have to have uh, a look ahead tracking.
Well, that's what I'm hearing. I'm just
I,
wanting someone to tell me that we need to do that because
yeah, I think it should be that anyway, but that's a personal feeling. But I think it's going to have to be look ahead tracking, because otherwise, if we're talking about a couple of minutes of angle, um, having to lead the planet by a couple of minutes an angle and then track into it again to pick up the return signal.
right. So basically,
So,
what we're talking about is an epoch of time and where the object is at that epoch. And what it sounds like to me is that when we initiate the track, we're going to look at an epoch that's in the future to put the telescope in the right place.
yep,
And then at the end of that, we have to recalculate the epoch behind us and then point the telescope at that position. And right
yes,
now, that capability doesn't really exist in the system. Now, the math and the timing and all that stuff does, but there's nothing right now in the software that allows us to say, "Hey, I want to look ahead 30 seconds or 2 minutes or something like that." So,
that's. I think it's going to have to be a look ahead system.
So
And
yeah,
those things are around. I think Marcus is using one in Canada. I think he's got a look ahead tracking. I'm not sure.
well, I'm not saying we can't do it. I'm saying I need someone to tell me that we need to get it done and get it done quickly because we're doing other stuff right now with the system that we're
Right.
investigating. So,
yeah, that was initially brought up in the first hour conversations, but I think it wasn't elevated to level that any actions,
right.
because from the receive perspective, there's no concern. You can slew your antenna, or you can let the object pass your beam width, not a problem. like you normally do. Well,
Right.
can't transmit, you have to be ahead because you need to accommodate this 2 minutes difference. Because when we transmit from the Earth, as soon as the signal leaves the Earth, our antenna, it's referenced to Earth. But everything else in a space are constantly moving. But by the time the signal approaches to the moon, I mean, to the Venus, the Venus already gonna be 2 minutes ahead. So,
Yes.
and that's our concern. So we keep trying it. We're never gonna end any reflections from Venus because we just passed the Venus.
Yeah, you're
So,
pointing in the wrong place. So
yes, correct.
you need the light travel time to understand how much forward and back you need to point with. So it's something
Correct.
that you do, but it's something if it's this important, I need to get working on it and getting people involved and making the appropriate changes and make
It's the
that
same like as anyone hunter and go hunt for ducks, right? You don't shoot at the duck when you see it, you shoot ahead of duck,
right,
and that's where you hit it. Exactly the same what we need to do here. So that's
right,
why I want to bring it up right now since we have 14 weeks ahead, right? So
right.
you guys I'm okay. Anytime you want me to come and do testing, I'm more than love to come. I have no
Okay.
problem. It
That's
cost me $50 to fly from Arizona on Frontier to Denver. If
yeah.
someone needs to pick me up at the airport because it costs $250 to rent a car, and I want it. So I rather 5 times fly than just to once rent a car. So anytime I can come, literally every weekend, because every other weekend Friday's off. I can even come on Friday to do these experiments. So make sure we work together as a team and achieve all these goals. And if 25 would be successful with it.
Say,
Okay.
Glenn,
Yeah.
this Bill, as a starting point, would you share your calibration presentation and report with Alex?
Yeah,
Just
let
so
me
we have a
talk.
starting place for this.
Yeah, let me talk to Lewis tomorrow. He's been doing collection of data on our calibration pointing stuff. We've been down there multiple times over the last couple months, and we've been doing calibration stuff. So
Yeah, you had a pretty good report on it at one point, and
yeah, so
that's a good starting point.
he's got the data on that. So I'll try to track that down. You know, my concern is, you know, there's a difference between assembling hardware and getting it working versus developing the software, testing it, and getting it working. So we just need to understand what we need as far as requirements, and then I'll talk to Lewis and Phil tomorrow and see what they have to say. But I think a lot of the stuff is there as far as the algorithms and the Astro code required to do the conversions, but we're asking it to do something that it just doesn't do right now. So let
And the
me,
reason I didn't include this on this chart here because it's not affecting me. It's not impeding me at any way. So I
right,
can continue focusing on the milestones and completion of the important parts. But in parallel, there would be upgrade to the electrical system. There would be upgrade to other infrastructure and perhaps software for a telescope. It's all going to be in parallel. But from my perspective, I just want to bring this up, my concern, so I have an answer. So you guys going to look at it so we know what's going on there.
okay. Well, what I'll do is like there's three of us that work on the software. I'll get with the other two guys tomorrow, and we'll talk about what we need to do to change to make this work correctly. We actually kind of looked at it in the past, so we can look at it again, and then I'll get back to you guys and let you know what we need to do. So
Appreciate it, man. Thank
thanks
you
for
very
letting me
much.
know what's going on. Thanks a lot.
Glenn, is Phil working with you as well? Phil
Yeah, he
Gaines?
is.
Okay. Yeah, I forget to mention him a lot. He's a quiet guy, sits in the background. He does.
He is. He's very quiet and he doesn't like crowds. So
Yeah. Well, he does a great job along with you and Lewis.
yeah. So let me talk to those guys tomorrow, and then I'll just send an email to everybody
Okay.
and see what we can do.
Okay. Thanks,
Okay.
Alex, for your timeline and Glenn for your input as well. And the timeline that Alex had up there, I've been purchasing some of this equipment's coming from European countries, and I had to one buy of about $8,000. I had to go back to the bank, get actual bank international bank transfer to get this done. And it took several days to get that accomplished in order. So that was maybe 3 or 4 delay from that. Hopefully they've sent that stuff by now to you. Have you received any word, Alex, on the from Kuhn Electronics?
No, I haven't received. So perhaps you mentioned as
Okay,
a
I'll go back and I'll send her an email tonight, so they'll have it in the morning.
yeah, it
In
would
the
be great
Germany
to
time.
I will 1 second. I can share one more thing then. So pretty quickly, so this is the list, and that's, as you can see, you ordered everything, and I actually received connectors and a cable from Dave. So I have a connectors with me. I brought it with me this weekend, but I couldn't take a cable, and they're really needed because cable needed for the side. So the
Yeah.
cable is in the Haswell. So that I'll complete it too. As you can see, all parts are ordered, but I only receive only this, which
Yeah.
is locally whatever ship, but I did not receive any international yet, and I need them as soon as possible because they are fundamental and essential parts to start assembly.
Okay. I'll get those power supplies to you when I get back from a Reno trip, and I'll get those to you. I'm not
Thank
sure
you.
what they were sent for to Colorado, but we'll get them back to you. Thanks again, Alex, and Paul. Of course, Paul's trying to lead this event up as well. He's heavily involved, and there's a lot of people involved in this project, as you can see, and good working between coordination between everybody is going to hopefully make this a successful project. Next thing I have on the list was we've been on here quite a while now is the installation of the radio astronomy feed. And Ray, you talked about this several weeks ago when I talked to you, but I haven't gotten with you lately. Is what's your plan on getting that back up and working for a few months, or are you?
Yeah, but I'm going to build a 250 megahertz feed for the dish and try to go down in frequency as low as I think we need to go, and the best frequency. And we're going to be looking for um, Jocelyn Bell's pulsar that we did not get at 1420 megahertz when we tried it here a month or so ago. So I want to build a lower frequency feed for the dish to try and get that pulsar and a few others, and we'll see how the dish and how we get pulsars at a lower frequency. We did it once at 408 megahertz and are about in that vicinity, and it worked really good. That's where we got our first pulsars, and so I'm going to try it down at 250 because that's a quiet band, and see if we can't get some more pulsars and start our numbers back up again. And so I'll do that, and then we'll take it back down in the middle of January at the latest, and have the dish ready for the EVE project. And so, but I do want to make one more comment while I've got it here, and that is on the tracking of the dish. I think if you guys run the numbers and take a look at it realistically, you're going to find out that we don't have to add any Venus windage, and it will just don't have to worry about aiming the dish ahead at all if you look at the numbers and considering the best possible beam width that we can have at 1296. And with that, that's about it.
Okay, Ray. Any questions for Ray? I know we've had the recent interest and past interest in the radio astronomy aspect of DSES. So, and this new exciting aspect of going to 250 megahertz, that's even more interesting to expand down to that frequency.
Is the 1296 feed still up, or when do you plan to put the 250 megahertz feed up?
I haven't got it finished yet. It's still actually in the design phase, but that will take me only a day or so to build. And so we should have it the next time I can get down when the weather's nice, and I can get somebody to go down with me to catch me when I fall.
Well,
all right.
please don't. The 1296 feed is still up, though. Is a question Dan asked.
The 1296 feed is currently up. Yes.
Okay.
Hey, Ray, it's Don. Wonder if I could be an Indian giver and get that 400 megahertz feed that I made back. If you're not going to use, if you're not
Yeah,
going to use it.
absolutely. If you, yeah, but do you want me to take the, we won't use it. We haven't used it right lately here, but we certainly could use it. But I'll send it back, but I'll take the back of it off. The
Oh,
mount that,
you've got a mount. Never mind then. That's okay.
oh, all right.
I've got enough stuff here to make another one. Don't worry about it.
Oh, okay. Thank you.
Yeah, no sweat.
So
All right, we've
yes,
covered a lot of topics tonight, and again, thanks everybody for the EME participation in the contest, and Bill Miller for getting everything hooked up so they could have a comfortable place to lounge and do the contest with the additional add of the heat pumps and the water heater and all that other stuff that was faulty there for a while. And everybody for the attended to keep the place clean. That's very important. It's a really nice facility. Paul stressed when I showed up with my dirty shoes on in October. He says, "Please take your shoes off," and I says, "Okay." And it's a nice clean floor in there, and we like to keep it that way. Hopefully, we'll have some money left over, maybe to put some gravel down, so the mud that we encounter getting to the building from our parking spots won't be there. So that's always another project down the road we can maybe get done as well.
Yeah, that's
Yeah,
true.
yeah.
I held quite a bit in reserve for that contingency, but we're also holding some in reserve for taxes and
Yeah.
utilities and such. So
Yeah. All right. Well, yeah, as utility goes, we'll be with the more people going down there during this time of year, our electric bill will be a little higher, but that's okay.
Yeah.
We're use out of the facility.
yeah, I'm real curious to see what happens.
Yeah.
We got to watch that for this next utility bill because we've had about 5 trips and have had the heat pumps on and have had the a lot going on down there. So it's kind of interesting to see what the utility bill will be.
Yeah. Okay.
That's probably a worst case month, in fact.
Yeah, probably so. That's all I have for tonight. The open discussion is here. If you guys want to hang around and continue talking, that's great. I'm going to check out of here. I'm in Reno here with my family, grandson, and they're busy in the other room having fun, and I would like to join them. So we'll say good evening, everybody, and we'll be on again. Try to do the science meeting next week. We'll have more information on that as well coming up later in the week. Check the website out for information as well, DSES Group IO for additional contact information. And we'll try to put more information out as more information we get on the EBE project. So thanks again, Alex, for the update. And again, Glenn and Lewis and Phil and all the other, and Dan for all the information you've provided. I haven't had a chance to look at that spreadsheet yet, but you've done a lot of work on that. So thanks again for doing all that work.
Thank
So
you,
Bill,
Myron.
you want to finish things up? I'm going to check out of here.
Yeah, I'm going to, if nobody has any official business left, I'm going to drop the recording, and then I'm going to leave the Zoom open, but I'll have to bug out myself. I'll just leave my window open here. We'll check on.
We had about 30 people tonight, so that was a really
Oh,
good
that's pretty
last
good.
minute change.
Yeah, worked out. Sorry it took so long to get it set up. Anyway, I'm going to stop the recording, and then I'm going to